Hello, welcome to another video. Today we're going to be shifting our focus from differentiation, which we've been covering for the last quite a few videos, to integration. So this channel will focus less on the basic rules of integration because I think that's better covered elsewhere. Instead, we're going to focus on just doing problems and applying the basic rules to more challenging situations, AP style situations. So what we're going to be doing today is going over a free response question. You can see here the mean score was just 1.5, so you can round that up to 2 out of 9. So this stuff is definitely hard, and you don't need to get every single question right to get a 5 on the exam. I certainly didn't. And yeah, a 5 is pretty far from 100%. So just want to throw that out there before we get started on this question. So at time t equals 0, we've got a cooling potato. And the internal temperature is 91 degrees at t equals 0. You always want to take special note of these initial conditions. You're guaranteed to use these if you find them. So I just boxed them because that's really important. Internal temperature is greater than okay, and something important to note about free response questions as we're going through is you're always going to use every single bit of information that they give you in general. Like if they give you a table, you might not use every single piece of the table, but you will use the table at least once throughout the questions. So that's an important pattern to keep in mind. You can catch your mistakes with that. So moving on with this here. So we've got a function h. Now you've got to understand that just because something is written as one variable does not mean that it isn't a function, right? Like if you're saying y of x, we usually say it's y equals like mx plus, this is a function, right? This is a linear function of x. But y and x are both functions, right? Y is a function, but x isn't. But they're both just written with one letter. So the reason why I'm pointing this out is because when we read this, we have to know that h is a function. H is a function of what? Is a function of t. And they also give us this notation right here, h of t. This is going to be very important for when we do this. And in fact, when I write this out in my work, what I like to do is I'll write this as h of t minus 27, just to emphasize to myself that this is a function of t and not just some sort of dependent variable. So h of t is measured in degrees Celsius and h of 0 is 91. So these two correspond to each other. They might not always give you this in mathematical notation. They might just exclude this portion of the sentence completely. And it's your job to be able to say, okay, this portion of the sentence is telling me that h of 0 is 91, right? But they've been particularly lenient with this question. They've given you that. Okay, so let's write an equation for this tangent at t equals 0, and then use this to approximate t equals 3. Okay, so let's start with the first sentence, right? We're going to write a tangent. So in general, if you're taking a tangent at the point x1 comma y1, then your tangent line is going to have the equation y equals m, x minus x1 plus y1. This is just point slope form, but we're just applying it here. And m is usually some sort of derivative. And in this case, it will be the derivative of h. So the derivative of h is dh dt. So we have that right there. So I'm just going to rewrite dh dt is minus 1/4 h minus 27. Okay, so what point are we interested in? We're interested in t equals 0. So we're going to have to evaluate this dh dt at t equals 0, right? So what does that mean? So 1/4 h, so remember h is a function of t, right? I'll write it like this just to make it crystal clear. So h of t at t equals 0 minus 27. right? Everything is a constant except for h. So h is the only thing that we have to actually evaluate. Now, what is h of t at t equals 0? Well, we know what that is. That's 91. So let's substitute that in right there. Okay, do a little bit of mental math. That should be 64, and you'll get minus 16. Now, this is not the answer, right? We got a number that is not the answer. This is probably less important in free response questions, but in multiple choice questions especially, you always want to check, like when you get a number, like take a step back and think about what you're doing in context to the entire problem. So what did we just do here? We just found a slope for a line. We did not find the tangent line. We have to apply that, but we found the slope because it's going to be useful to write the line, the equation of the tangent line. So okay, let's figure this out. So m is our slope. We know what m is. It's minus 16, and now we've just gotta sort out what x1 comma y1 is. So that's the point of tangency to our tangent line, and in this case they just give us what that is, right? So h of 0 is 91. So our x, well, really it's t and h, right, for our situation, but it's going to be 0 comma 91. Okay, so now you just got to plug that in. The only thing that you want to be a little bit careful of is just make sure you switch the variables. Like y and x are just representing the independent and dependent variables. So you're going to want to switch the variable when you write it out. So y is actually, y is going to be h equals m. Okay, what was m? It's minus 16. X, no, our independent variable is now t minus x1. Okay, that's really our t value, 0 plus 91. And we can simplify this a little bit, t plus 91. Okay, so we're done with one portion of the question. Now we've got to use this equation to approximate the internal temperature at time t equals 3. Okay, so let's find h of 3. It's going to be approximately equal to 16 times 3 plus 91, right? So you just plug it in here. That's what they're asking you to do. So that should be minus 48 plus 91, and then that'll be a 43. That's h of 3 is about 43. So there's our approximation, and remember we had to check for units. So, right, because we're approximating an internal temperature, and their temperature is measured in degrees Celsius. So we have to write that. They made dock points off if you don't write the units, so make sure that you do that. Okay, let's go on to this next part here. So we're using the second derivative to determine whether it's an underestimate or an overestimate at time t equals 3. Okay, so let's just review for a second how we're going to use the second derivative. And I'm going to draw sort of two pictures here. I hope it's clear what I'm drawing it for. So let's suppose that this is the point of tangency for both of these situations. And on the left graph, right, the graph is concave up. And then on the right, it's concave down. And typically when you approximate with a tangent line, you've got like this point that you know that's on the function, the point of tangency, and then you've got some other point that you're approximating the value of with this line. So here the star represents the approximated value, and then this like vertical line here, maybe I'll make this an icon a little bit more clear. So I'll make this like a circle. So this open circle sort of represents what the actual value of the function is, right? And if we were to do something similar, right, so this would be the approximation. I'll just write approx here. And then this open circle is what the function value actually is at that point. So whenever you're determining whether it's an overestimate or underestimate, right, the thing that you have to keep in mind is this second derivative has to be like the same sign throughout your entire interval. from your original point that you know all the way up to the approximation, right? Because otherwise your function can do some crazy thing where it's like, oh, the second derivative is positive here, but then it just goes negative somewhere in between, and then you can't tell whether it's an underestimate or an overestimate. So on the left hand side, we know that this will be an underestimate, right? Because our star is underneath the open circle. But then over here, this is an overestimate, right? So yeah, basically the thing that I want to highlight here is you have to make sure to check that this entire interval, the sign of the entire interval is the same, and it supports your conclusion about whether it's an underestimate or overestimate. So let's figure out what the second derivative with respect to t is. So we'll just erase this real fast. Okay. So we know what the first derivative is, right? Let's just write that out. Equals minus 1/4 h of t, right? I again gotta write it out as a function. At least for me, that helps a lot, just for mental comprehension of what this expression actually means. And then we're going to take the second derivative. That means we've got to differentiate the first derivative, right? And then what is that? Well, you're differentiating this expression right here, h of t minus 27. Close. Okay, so this minus 1/4, we can just expand this actually, right? So let me do that. Minus 1/4 h of t plus 27 over 4. And then what happens is this part's just going to be 0 when you differentiate it, and this part's going to be minus 1/4. That's a constant, and then you're multiplying by dh dt, right? If you want, you can write this h prime, but it's really the same thing. And that, what is that? That's our second derivative with respect to t. Okay, great. Now we've got to determine whether it's an underestimate or an overestimate. So what did we do? First, let's just find what the sign of dht is, because interestingly enough, we know what it is at h equals 0, right? We could find that because we know what the value of dh dt is, but we don't quite know what it is at t equals 3. And like I said earlier, you need to make sure that you cover your entire interval. Make sure that the sign is the same from your entire interval. So in this case, it would be from 0 to 3. You have to make sure that the sign is the same in your entire interval. So how do we go about that? Well, what is the one piece of information we haven't used yet? Well, we haven't used this initial condition, but that won't be useful for now. Okay, this is something to look at. It's greater than 27 degrees for all times t equals 0. What does that mean for the sign of dh dt? And the sign of dh dt matters for the sign of this second derivative, right? So we know that dh dt is a minus 1/4 and then h of t minus 27. Right? But the thing is, this is always going to be bigger than 27. So that means that this portion of the equation is positive, and that implies that when you multiply a positive number by a negative number, that will be a negative. So you know that dh dt is less than 0. For all t is greater than 0. That's important. You need to state this for all t is greater than 0, because that means that it'll work. It'll work for all the way up to 3. At 0, right, we have to include 0, and we know what it is at 0. It's negative. We found it out, right? It's negative 16. So that's not something to worry about, that it's that this t interval doesn't include 0. So, okay, but then what does that mean for the second derivative? Because we want the second derivative, right? Well, you've got a negative number multiplied by an always negative number, so you're going to get a always positive number for all t is greater than 0. Okay, great. So we know that the second derivative is always positive, which means it's going to be concave up. from 0 to 3. So what was our approximation here? Got a 0.91, so I just like sketch this. So maybe this is what the graph looks like, I don't know. And here is our line, and this is how I always do it on the exam. I draw like a quick sketch like this because I don't memorize like, oh, if it's concave up then it's an underestimate or something. No, it makes a lot more sense when you draw it out. So here is what our actual point, maybe that's our 0.91, and then we've got our time t equals 3, right? So here's our approximation, and then there's our actual value. So we can see clearly that the star is under that open circle, so this is going to be an underestimate. So we know that part A was an underestimate. Okay, so yeah, and some important things that I want to emphasize again. You have to make sure that you check all the way from 0 to 3. You can't just like say that it's positive at one point and then conclude that that's going to justify that it's an underestimate or overestimate. Because you can do all sorts of crazy things. Like maybe if you argue that it's true, it's positive here, that doesn't guarantee that this point will be an underestimate, because for all you know, it could just be positive right there and then just go boom, negative, like right after, right? And a similar thing happens if you try to justify it with only the other point, with only t equals 3. So all right, approaching our final part of this question here. So we've got a function g satisfies that, where g of t is measured in degrees Celsius, g of 0 is 91. Okay, so hopefully when you look at this problem, you know that this should involve a separation of variables, because we've got the derivative here and we're trying to find what the function is. So yeah, let's just get right to separating. So g minus 27 to the 2/3. Now you're going to want to separate variables. They almost always, I think always, give you a point for separating variables. So you definitely want to write this stuff down. But we have a problem. We can't quite integrate yet because that's a g, and we're integrating with respect to t. And g, like, you have to move this over here so that it matches. So let's do that. So I'm just dividing by g minus 27 to the 2/3. And I'm going to leave that minus sign just hanging there because I don't want to have to deal with it on the other side. So now what happens? Well, we can do a u sub on the left side, right? Because this is a rational function and you've got some linear term here. So u sub is a good try, and in this case that's what we'll end up doing. And there's no scaling factor we have to worry about. So 1 over u to the 2/3. Oh, let's integrate. Sorry, did not write this symbol there. It's very important. They're somewhat strict on notation on the AP exam, so you definitely don't want to like just write like what I did earlier. So that should be du, right? Because we're integrating with respect to u. And then what is this really? Well, that's a minus 1 dt. And if you integrate that, right, you should write the integral sign on both sides. But when you integrate this, you'll get a minus t. And then you add your constant of integration. You definitely do not forget your constant, right? You can do all the work, but if you forget the constant, then they will penalize you heavily. If you look on the scoring guidelines, I think it's like you can only score like 2 points out of 5 or 6 if you don't include the constant of integration. So definitely remember to do that. Okay, so to finish this side, we're going to write this as a negative exponent, so then we can apply the power rule. So now we're going to add 1, so minus 2/3 plus 1 is going to be 1/3 over 1/3. And you could write a plus c here, I mean technically, but you can also just always move it to the other side for whatever value of c you pick on this side. So like you normally only write it on one side just because it doesn't matter at the end of the day. So okay, but we've got to bring this back into the G world. So let's make this a G minus 27 to the 1/3, and we'll bring the 3 out here, right? Because we're dividing by 1/3. E plus C. Okay, so they want an expression for G of t. So we want to isolate G. So let's do that before we plug anything in. So G minus 27 to the 1/3. I like how they neatly avoided even roots. If it was even roots, then we might have a little bit of a problem isolating G, but now we have an odd root, so we don't have to worry about that. And then we're going to cube this expression. So G minus 27 equals that value cubed. And then all you have to do is drag the 27 over to that side. And we're not done. We have not found our constant, what the value actually is yet. So let's do that. We've got to use the initial condition for that, right? Finally, right, I told you in the last problem, in the last part, that this information wasn't useful, but now it will be. So let's write G of 0 is 91, right? So what is the value of G? It's 91, right? And then minus 0 over 3 plus C cubed plus 27. Okay, so first let's subtract 27, and you should get 64, and then that would just be a 0, so we just write C cubed. Great, and now all we have to do is take the third root, right, and then we'll get 4 equals C. Alrighty then. So we found out our C value, but now we just have to plug this back in. So we'll get G equals T minus T over 3 plus 4 cubed, and then plus 27. Alright, so there's our expression for G of t. That was sort of the hard part. And now we've got to find the internal temperature at T equals 3. So G of 3 is going to be minus 3 over 3 plus 4 cubed plus 27. So now it's just a somewhat arduous task of evaluating this. But this is a no calculator FRQ, so it's not very bad at all. And you'll get to 54. And remember, we're estimating a temperature, so this has to be degrees Celsius. Right, okay, and at this point, we're pretty much done. Now, one thing to keep in mind, right, we got a value for t at t equals 3, and the earlier part over here, we estimated what it was at t equals 3, right? And here we said that it was going to be an underestimate. And so something to keep in mind when you're doing these FRQs is, like, most of the time these parts are going to be like interconnected with each other. So a good thing to ask yourself before you finish off any question really is, does my answer make sense in the grand scheme of things? Like just taking a big picture view here. And like, okay, our value was 54. That's our actual value. And our estimated value was 43. So yeah, that matches that it's an underestimate. So that's something you want to keep in mind, because you can definitely catch mistakes. Actually, when I was doing this FRQ for the first time, that's how I caught my mistakes on one of the parts. Is I saw that my answer didn't make sense with what the other part said. So yeah, just make sure that your answer makes sense relative to the other parts or of the question. So yeah, that'll be it for this video. This is a lengthier one, and I'll see you guys in the next one.